Greetings everybody, and welcome to our fourth example of working with vectors. So in this case, what we want to take is a linear combination of a couple of vectors in 3 dimensions. And so the first thing that we have to remember is that scalar multiplication is always done component-wise, as is vector addition. So if we have a scalar c times a vector, let's say vx, vy, and vz, that the scalar of that vector, each component just gets multiplied by c. So I've got c times v sub x, c times v sub y, and c times v sub z. Likewise, if I have two vectors, v sub x, vy, and vz as one of them, and then another vector, w sub x, w sub y, and w sub z as a second vector, adding them together is just done component-wise. So I add the x components, which will just be v sub x plus w sub x. Add the y components, v sub y plus w sub y. And finally, add the z components, v sub z plus w sub z. And so for this particular problem, what we have is a minus 5 times my vector negative 1, negative 2, 4, plus 3 times the vector negative 5, 6, and negative 7. Well, distributing that scalar, actually doing the scalar multiplication, is going to give us a vector of 5, negative 5 times negative 2, giving us positive 10, negative 5 times positive 4, giving us a negative 20. Doing the same thing with the 3 times the negative 5, giving us negative 15, 3 times 6 gives us 18, and 3 times a negative 7 gives us a negative 21. Now, if we want to add those two vectors together, everything is done component-wise. So I have 5 plus a negative 15. I have 10 plus 15, or rather 18. And I have negative 20 plus a negative 21. And so I end up with a final answer of negative 10, 28, and negative 41. And so what is our final answer? Our final answer is answer A. I hope this has been informative, and I will see you guys in the next example.